A+ലേക്കുള്ള വഴി ഇനി തനിയെ തുറക്കാം. Subscribe to the ENCLAPS channel. Ring the bell button and open success. It's that easy.
Hi. Physics is a subject which has an immense connection with our day-to-day life. Have you ever thought about the energy that is distributed just above your head through the electric poles on both sides of the road? You may have many doubts about such instances. So, let's discuss the transmission of energy through these electrical lines and how it reaches our homes. Kerala is gifted with loads of rivers. Making use of this, electricity is generated in dams using the power of water flow. Hydroelectric power plants are the main source of electricity in Kerala. How does the electricity generated in hydroelectric power stations? Let's discuss. As the water flows down the dam through the pipe called penstoke, its kinetic energy is used to turn the turbine. The generator converts the turbine's mechanical energy into electrical energy. Later, this electricity is transmitted to households through distribution networks. Now, let's see how the mechanical energy is transformed into electrical energy inside the generator. Three-phase AC generators are used in power stations. In power generators, 3 armature coils are arranged around the field magnet. That's why it is called the three-phase AC generator. We already mentioned power stations. What is a power station? Power stations are places where electricity is generated on a large scale for distribution. There are different types of power stations. Earlier mentioned hydroelectric power stations are one of them. Idamalayar hydroelectric project and Idukki hydroelectric project across Periyar river are examples for this. This is the working model of a three-phase AC generator which can be seen in hydroelectric power stations. Here, the 3 armature coils are arranged around the field magnet at an angular separation of 120 degrees. This is the motionless part of the generator. Thus, it is called the stationary part or stator. Another important part of this is the field magnet connected to the turbine. When the water reaches the turbine, it rotates, which causes the rotation of the field magnet. Therefore, the field magnet in the generator is called the rotating part or rotor. The field magnet we used here in the working model is a permanent magnet, whereas in the actual power stations, the field magnet used is an electromagnet. To provide the sufficient electricity for the electromagnet, a secondary generator is used. How mechanical energy is transformed into electrical energy inside the generator? The water flowing through the penstoke strikes the turbine. The kinetic energy of the water rotates the turbine. Turbine is connected to the field magnet. So, when the turbine rotates, the field magnet also rotates. When the field magnet rotates, an EMF is induced in those 3 armature coils and as a result, AC current is induced in them. 3 alternating currents of different phases are generated simultaneously in the 3 armatures. In each armature, maximum and minimum EMFs are generated at different instances. Therefore, it is called 3-phase generators. Now, you understand how mechanical energy is transformed into electrical energy inside the generator. The electricity generated in dams is transmitted to different places. When electricity is transmitted to distant places, there is loss of energy in the conductors in the form of heat. This is known as transmission loss. Here, the energy loss is in the form of heat. We already studied that the heat generated is directly proportional to the square of the current in the conductor. So, we can reduce the transmission loss in the form of heat by reducing the strength of current at constant power. We can use a step-up transformer to reduce the current in constant power by increasing the voltage, which results in the reduction of heat generated. For example, if the voltage is increased by 10 times, the current will be decreased by 1 divided by 10 times. Therefore, heat will be reduced by 1 upon 100 times. The voltage is increased up to 220 kilovolt at the power station itself. Depending on the distance to which the transmission is to be done, different voltages like 110 kilovolt, 400 kilovolt are also made use of. Step-up transformers and step-down transformers are used in different places during electricity transmission. Step-up transformers are used in power stations because voltage is increased in the power station itself for reducing transmission loss. Step-up and step-down transformers are used in substations because in substations we have to increase or decrease current. Step-down transformers are commonly used in distribution networks. The transformers we usually see in households and streets are step-down transformers. The current reaching those transformers will be of high voltage, but 230 volt is the required voltage of household purposes. So, the voltage is regulated using step-down transformers before distributing them to our houses. Now, we have learned about transmission loss, regulation of voltage using step-up and step-down transformers in power stations, substations and distribution networks.
3 ലക്ഷത്തിലേറെ വരുന്ന ചോദ്യോത്തരങ്ങൾ ഏറ്റവും കുറഞ്ഞ ചിലവിൽ സ്വന്തമാക്കുവാൻ ഉടൻ തന്നെ ഡൗൺലോഡ് ചെയ്യൂ ENCLAPS the Learning App.